Hello class, today we're covering lesson 3 in chapter 5, equivalent equations. And we're going to just start reading from page 193. If the 2 bricks and 3 1-pound weights on the left-hand pan in the drawing above exactly balance 9 1-pound weights on the right, how much does each brick weigh? So we have an illustration here where we can see the 2 bricks and then 3 1-pound weights, and then we have 9-pound weights. So we have to, with this picture, determine if these are equal, they balance. So the keyword balance means they equal. We're trying to determine what the weight of each brick is. Okay. Now, because 3 1-pound weights on the left are balanced by 3 of the 1-pound weights on the right, the 2 bricks are evidently balanced by the other 6 1-pound weights. So let's just go ahead and draw this up here on the board. Let me get my pen. And again, you have to stop and think logically to say, well, if, like they said, we have, let's see, 2 bricks, okay, and then we have these, let's call these 1-pound weights. They sort of look like little triangles. And then we had 9 of them over here, right, as they illustrated. So let's draw them as they're illustrated. And that would be 5. And now we have 9 weights. Okay, so our scale would say that these are balanced, so that means they're equal. Now we know, for instance, that these 3 1-pound weights right here would be equal to 3 1-pound weights over here, right? So let's just take the top 2 plus another one. So we know those are equal, right? So with knowing that, we should be able to determine, if we were just to remove these off the scale, let's say, and we would be left with these 2 bricks over here, and we'd be left with 6 1-pound weights, right? So by knowing this, we should be able to determine how much each brick weighs. If the 2 bricks have equal weights, each one must be balanced by 3 of the 1-pound weights. How do we know this? Well, if we divide this by 2, right, we would end up with 1 brick. And if we divided this by 2, okay, so we're dividing by 2. Let me just put like a little dividing by 2. Now, why would we divide by 2? Well, we have 2 bricks. We want to know the weight of 1 brick. So we divide here, but notice what we did was we divided the other side as well, and we ended up with 3 1-pound weights, right? Because we had 6. So now we know that 1 brick is equal to 3 pounds, or 3 1-pound weights. A balanced scale is a good model for understanding algebraic equations because the reasoning that we use to solve this puzzle is identical with the sort of reasoning used to solve equations. If we let x represent the weight in pounds of one of the bricks, then the weight of the on the pan on the left is 2x plus 3. All right, so this would have been 2x plus 3, right? 2x plus 3. Well, how do we know that? Well, we have 2 times, these would be x, they're unknown, right? And then we have the 3, so we could say 2 times x plus 3, and we can say that that's going to be equal to the weight on the other side, on the right, which is 9. So we could have written the equation 2x plus 3 is equal to 9. Compare the method for finding the weight of one of the bricks illustrated at the left below with the method used to solve this equation shown at the right. So we can see on page 194 we have this sort of the same drawing, and we can see the steps here. The boxes represent the bricks and the circles represent 1-pound weight. So obviously we're going back to our little number trick in a way, but again, let's just use this illustration. Steps in finding the weight of the brick is on the left, and steps in solving the equation. And we're going to just simply follow pretty much what we did before. We had two bricks and 3 1-pound weights, and then 9. Then we remove 3 1-pound weights. Now I did that up here. I removed these 3, okay? And now notice what happens to the equation. Well, we subtracted 3. I'm going to bring this all the way up to here and rewrite this. 2x plus 3 is equal to 9. So what we did in the first step is we subtracted 3 from each, right? So let's do that. We can write 2x plus 3 minus 3 is equal to 9 minus 3. Okay, as long as we're doing this to both sides, then our equation remains to be true. Okay, another way, if it's simpler for you, you can feel free to do it this way. Some people feel a little more comfortable with their old math technique of just writing minus 3 and they're subtracting 3. Now be careful feeling so comfortable with this, because you won't necessarily in a more complex environment have the same capability. Let's just say you won't be able to illustrate it as easily. So negative 3 being subtracted from both would leave us with 2x, which is equal to, well, that's 3 again, 2x plus 3 minus 3 is 0, so it's 2x, and then 9 minus 3 is equal to 6. So again, we're back to where we were here with 2 bricks, and we had 6 1-pound weight. So now the equation 2x is equal to 6 represents that subtracting 3. Now, if we were to remove half of the contents, and that's where we divided by 2, right? So we divide each side by 2. All right, removing half, we would be left with 2 over 2, which is 1. So we have x is equal to 6 divided by 2, which is 3. Okay, so this is basically how we solve equations. We call it solving for x. We call it simplifying an equation, solving it for a particular variable. All equations on the right, reading on page 194, all equations on the right have the same solution because they are equivalent. As you can see, we made changes to the equations, but they always remained equivalent. In general, and this is very important, any equation can be transformed into an equivalent one by performing any one of the following operations: adding the same quantity to each side, subtracting the same quantity from each side, multiplying each side by the same quantity other than 0, and dividing each side by the same quantity other than 0. Key words that we're seeing here are adding, subtracting, multiplying, dividing. We're also seeing the same quantity, okay? Same quantity all the way down. And we're also seeing each side. So there's 3 things here. You can add, subtract, multiply, and divide as long as we use the same quantity, obviously the same function. So we can't just add on one side and multiply on another. You'd have to be able to add on both sides, subtract on both sides, multiply both sides, divide both sides by the same quantity. Okay, these operations can be used to solve equations by changing them into simpler equivalent equations. The idea is to undo each operation indicated in the equation by performing the inverse operations on both sides. So if we were adding 3, well, let's subtract 3. We're multiplying by 2. Let's see, we're doing the inverse here. We were adding 3, so we subtracted by 3. We're multiplying by 2, well, we divided by 2. And ultimately, we are undoing all of those operations until we're left with one variable, x. X in this case was equal to 3. So the idea is to undo each operation indicated in the equation by performing the inverse operation on both sides. And here are some more examples on how it is done. If we look at example number 1, we solve the equation negative 3x is equal to 12. Now this equation says that if a certain number is multiplied by negative 3, the result is 1. Well, to solve it, we divide both sides by negative 3. Okay, key there is to use that negative. If you just divided it by 3, then you would end up with negative x. So if we divided both sides by negative 3, we would end up with x is equal to negative 4. Okay, and if you plugged in and you substituted negative 4 for x, you'll see that 12, well, you have negative 3 times negative 4 is equal to 12, and 12 is equal to 12. So you can always plug in your answer to determine whether you got the right one. Okay, particularly be careful with positives, negatives. Now we have another one here. Solve the equation x plus 7.2 is equal to 0.9. Now, this equation says that 7.2 is added to a certain number, and the result is 0.9. To solve, well, we subtract 7.2 from both sides. See, we had a plus 7.2 in the first equation. We were dividing by negative 3, so we're multiplying by negative 3. We divided by negative 3. Here we're adding 7.2. Well, let's subtract 7.2. But remember, we do it to both sides as we see here in our book. And our answer is x is equal to negative 6.3 because we're subtracting 7.2 from 0.9. And if we put it in and we check negative 6.3 to see if it makes the original equation true, we'll see that 0.9 is equal to 0.9. Okay, and then we have our last example. Turn over on page 196. We have solved the equation 4x minus 1 is equal to 19. Now, here there are a couple of operations that we need to quote-unquote undo. So we have to determine which is the first one we do. Well, we have to isolate the variable. That's the term that I like to use. And let me clean up my board here quickly so we can go over this one on the board. But isolating your variable, it means you're going to still have the coefficient when you take your first step, but ultimately the goal is to just isolate that variable and to show. When I say isolate, meaning I want to see x completely alone on one side of the equation. So let's go back and let's rewrite this. 4x minus 1 is equal to 19. So the first step, now you might say, well, I need to isolate the x. I'm going to divide this by 4. That wouldn't be the first step because we still have minus 1 here. And we really want to take a simple approach, and the simplest approach would be to remove this term so that we only have one term with our variable. So that's step number 1, is to get that term all by itself, and then we'll remove the 4. So what would we do? Well, we would add 1 to each side, right? So we're going to add 1, and what would we get? Okay, well, we get 4x and negative 1 plus positive 1 is equal to 0, and 19 plus 1 is 20. Now notice this was subtraction, so we had to add. We had to do the inverse. Now we're left with 4x is equal to 20. Now we can go ahead and do the inverse operation of multiplying 4, and that is to divide by 4. And you notice that we'll end up with 4 over 4, which is equal to 1, which means x is equal to 20 divided by 4, which is 5. Okay, now you can go ahead and, as you can see in your book, you can plug in and always test out your answer. 4 times 5, which is the x value, minus 1 is equal to 19. Well, does that work? Well, we would end up with 20 minus 1 is equal to 19, and we get 19 is equal to 19. It's good to check your work just to make sure that you didn't make a mistake. Sometimes we make simple mistakes. 20 divided by 4, oh, that's equal to 4. Is it really? Well, if we went in here and we would have put 4 in here, we would have found out that that was the wrong answer. And again, sometimes we just make simple errors with math, but if we check, we can always catch our errors, go back and correct them, especially on your test. It's very important that you check your answers. Okay, so you have exercises that you'll be doing in set 3, and we'll have a review video set up for that.